Hello, everybody. Welcome to the Create Invent podcast. I'm here with my co-host, Jeremy Cook, and joining us today is Hash. I can't tell you what company he works for because it's illegal for me to tell you that. But he's been reverse engineering smart power meters, the electricity meters that are on the side of your home that report to the power company and tell them how much money they have to charge you every month. How are you doing today, Hash?
I'm doing real good. Thanks for having me on the show.
Thanks for being here.
So now, Hash, as far as what we have you on for, you reverse engineer a lot of different things, and especially smart meters. So I guess just for our audience, what do you say is reverse engineering? How do you define that even?
Yeah, so I guess at a really high level, I've just always enjoyed taking things apart. So I like taking things apart. I like learning about them. And I didn't know what that was called when I was a kid. It was just taking apart my toys and breaking them, and then eventually being able to take them apart and put them back together. And then eventually learning what those components do and trying to modify things and change the way they work. And then, as I got older, I realized, that's reverse engineering is what you're doing a lot of the times. And then as I take things apart now and really dive into them, it's kind of like, I tell people it's like taking a puzzle and, a million pieces turned upside down with no picture and trying to put it back together piece by piece. And so it can be tedious and everything, but it's a fun challenge. And I like the challenge more when it's a really black box kind of challenge, you could say, where there is no documentation on things and you really have to just go figure it out on your own. Just because you can Google so many things today and just find the answer so fast that it's fun to have a challenge where you can't just find the answer real fast. Like, you have to figure it out. And so that's usually the kind of road I go down, which smart meters seem to fit that bill a bit.
Sure. All right, so smart meters is I guess what you like to hack. Is that kind of your favorite target, if I can call it that?
I would say so for right now. So this is a smart meter for anyone that's wondering what a smart meter is. It's the thing that's on the side of your house. It's usually got a little thing on the screen here, and it's telling you how much power your house, your apartment, or a business is using. And so I would say that my background and what I'm good at, I kind of started out as an embedded engineer early on in my career. And so I'm very comfortable with hardware, with, working with hardware. I've always enjoyed radio. I had an amateur radio license when I was a kid. And so that mix of things, devices that transmit, wireless communication, a lot of times things aren't completely understood about different wireless communications and how secure they are. So all that stuff, it all kind of fits in where I feel like is my wheelhouse. And so that's why I think when I started working on smart meters, it hit all those points. And so I kept diving in further because I felt like, hey, this is something where I'm really comfortable in this zone. I'm not as comfortable working on like a big software project or something, for example. So I don't go towards that. I go more towards hardware.
Sure. And these smart meters, basically, they're on the side of your house. Like you said, they keep track of how much energy you're using. And then they communicate, I believe, they use a mesh network sometimes, or even a cellular connection to basically dial home to the power company and tell you how much you owe.
So there's a ton of different standards. I've focused a lot on what's available here in Texas and kind of what's on the side of my house and looking at that, right? But there's a ton of different standards. There's all different ways wirelessly they can transmit back. Then that just on, like, you could say a proprietary mesh network or a proprietary protocol. Sometimes there's a truck that drives around and just receives messages from some meters. They can have cellular modems in them. Some countries have cellular modems and they're on a cellular network. Sometimes it's power line communication, so they'll actually communicate over the power line. So some countries, a lot of it is by the standards of the countries and what's allowed and how the grid is maybe laid out and things like that. So it's just it's all across the board. Yeah.
So when you say a mesh network, so basically these smart meters, each one is talking one to another, and basically it filters down to like a central hub. Is that kind of right?
This is just random stuff I have. So here's our picture. So these meters right here, they all transmit and they're broadcasting constantly. So people say like, oh, they transmit your information once every 15 minutes or once every hour or something. They're constantly transmitting, like more than once a minute. They're transmitting status stuff, broadcast messages, all kinds of network things to help other meters find and join a network. So they bounce those messages between each other. So you could think from house to house to house. And then you'll drive around and you'll see, especially out here, on a pole, kind of a bigger type white device that's a router. So it's picking up these messages, sending it up high, and then transmitting it back to like a substation at a power company. So there's a lot of technology in the meters that are forming this big kind of self-healing mesh network. If you park your car in the driveway right in front of the meter, it might block its transmission path, and so it has to figure out how to get the data somewhere else. It might log it internally for a while before it sends it back. So there's a lot of complexity, I guess, in that mesh network to route that traffic back to the power company.
The neighbor that parks his noisy Wi-Fi Tesla in his driveway is goofing up the power company.
Could be anything that's blocking it. You never know. And so they have memory chips inside of them that'll store stuff, if it's temporarily blocked or blocked for a longer period of time. And it's a two-way thing, so it's not just transmitting back to the power company. The power company can actually send messages down. So here in Texas, you can go to a website called smartmetertexas.com or .org. And if you go in there and it's linked to your power provider, you can say, tell me what my instantaneous power usage is. And in about 10 seconds, you can watch the traffic with software-defined radios. You'll see a message get sent to your meter. Your meter will turn around and send a message back. And so you can see, hey, in about 10 seconds from wherever the main headquarters is, it bounces a message across that network to your meter and back and shows your instantaneous power usage.
That's pretty awesome. I guess I always think like, if you were the technician, working at a call center at the power company and people call you and just give you all kinds of grief about something or other. I mean, I guess you could just press the button and flick their power on off, right? Is that
you could
you'd probably get fired, but
so here, let me show you in the back of the smart meter. So this is the back half of it. The front half has a circuit board that's doing all the measurement. The back half, this is actually a massive relay. It can switch 200 amps at 240 volts. So it's like 48,000 watts, I think is what it is. So, and it can do that a couple thousand times is what it's rated. So it's meant that, especially on networks where you might pay for power, like a pay-as-you-go kind of power provider, if you don't pay your bill that month, they can just send a message right down in that same 10-second time frame. It can come down and tell that relay to turn off, and boop, all your power goes out. So that also was real interesting to me when I found out that inside of every single smart meter is basically a huge relay that you can turn the power on and off, and that some signal that gets sent down can do that. Then it's kind of the hunt for, what's the signal?
And these meters that you have all behind you here, they'd be the kind I would have on my house here near Dallas.
Yeah, most likely. They're all pretty similar out here. They all, because Encore is a big provider out here, and then there's a lot of smaller providers, but they all seem to have kind of standardized on pretty similar meters.
Yep.
So I got to ask, have you ever, flicked somebody's power off? And you don't have to tell us, but.
Well, definitely if I did, I wouldn't tell you.
Okay, well that's
so. No, for the record. But what I would say is that a lot of what I'm doing is looking to see how you can communicate with the meters. So how I can build a device that can transmit on that same network, and also once I'm able to send messages to them and have them receive those messages, then what can you do? Can you fuzz it and cause issues? What is the message that would ultimately switch power on and off? I'm sure it's not a very simple message, like it's, it might be a signature of some kind that's needed to actually do it. Like they are fairly complex devices, but I know that, I don't know how many people are trying to attack it, so you never know how secure it really is, in the sense of, what level of attack is it going to? So I would say it's like this. There's two sides kind of you could think of to the network. There's someone that goes over an IP side of the network and gets a hold of some main control center and then sends messages out to turn things off. I think that's a traditional attack vector people think about, is someone comes in over the internet, gets some malware or something in, and then takes control of industrial control systems. There's the other end, which is you're able to come across the wireless mesh network side that people might not be thinking someone would come across, and then send direct messages directly to these devices. So that's been the direction I've looked, that is maybe a little different than what you traditionally see people look at.
So I could drive down the neighborhood with a truck and just be spamming out "turn off."
Yeah, you could do. Yeah,
I'm
I mean,
not saying
technically,
I can, but
so the interesting thing is when the meter turns off power, it doesn't turn off power to itself, right? It's switching off power down to the house, so it's still on even when it turns the power off to the house. So technically, if you could send out a message, you could just have them relay it and broadcast it across their own network to all the meters.
Even worse, yeah,
right. So they're. Yeah, so it does open up possibilities if you're able to figure things out. But like I say, it's definitely it's no easy task. But I think it is an interesting one to play around with.
Yeah, and you said that the relay is only rated for so many switches. That could be another attack too, right? Just flip somebody's house on and off 2,000
I guess it
times,
could.
and then somebody has to come out to fix it.
Yeah, I mean if someone was able to turn something off and then change the firmware so that it wouldn't accept a turn on message, then that would be pretty disruptive, right? Because then somebody would have to come out and physically do something or something else, So there's a lot of things like that. Nothing that's happened as of yet that I'm aware of anywhere, but I think the less that people look at it, the more likely it is something like that could happen. Right, especially as the tools like the software-defined radios and these other things I use to analyze them, the cost of those keeps coming down and down and down, and so it means more people can play around with it, right?
Sure. What's interesting, I guess everybody was quite worried about cyber attacks and stuff in the last couple of months, especially, and I guess I haven't really heard much about that. I'm kind of surprised. Do you feel like things are maybe more secure than people thought, or you think it just hasn't been done, or what?
You mean just kind of in general, like the higher alert that went on about watching out for?
Well, yeah, I mean, as far as we just talk about Russia and Ukraine and stuff like that. You talk about hacking and stuff like that. People were quite concerned about that kind of thing, but it just doesn't seem to have happened here, at least at what we've heard of. You think that was maybe things are more secure than people thought, or you think they just haven't considered it?
I'd probably be commenting outside of my realm of expertise in that. I might think maybe things are more disconnected. Like I think the security and these devices, on the whole, there's not a lot of times they're meant to last in the field a long time. Mm-hmm. So, years and years that a lot of these systems are meant to last. Smart meters are meant to last like 15 years. That's the ROI for the power company. They stick it on your house and it has to last 15 years. And so the microcontrollers and things like that are in them, right? Like all the vulnerabilities that can be found and stuff like that, like 15 years is a long time to last. And that's the same thing with these other industrial control systems. So, I think maybe they're doing a good job of keeping them bridged away from other stuff, or things like that. Or it's just, nobody hears about it because they don't want to, usually it's bad press for a company or for anyone else. So that's the challenge with a lot of this stuff I find, is that the desire to keep things quiet and to not have things be publicly known drives a lot of stuff. And so that was a big push of when I was working on stuff to say, how do we do it kind of more in the public's eye, so that if there are issues or things people should know about, we just all find out about it at the same time. And it's not something that's done hidden away,
Sure. Well, what you do with this experiment with this, do you feel like it makes you maybe more paranoid about what could happen?
Well, I mean, from being out here in Texas and seeing the power go out, in that kind of February, that was a little concerning to see, how quickly things kind of seem to fall apart if the power goes out, right? Especially when you have an extreme, like a cold temperature or a hot temperature or something else. But I guess working on it, it doesn't make me any more paranoid than I guess knowing about anything else. I just know that things usually, they aren't as secure as people are telling you. Just kind of on the whole, right? And that if you don't understand how it works, then that should be concerning in itself. And I think it should be concerning for a lot of the people that, that purchase these systems and deploy them, because you're kind of just going off the promises of the vendor and what they're telling you of how they work. And analyzing it, it can be a bit complicated, like it's, specific sets of skills and things you need to look at these things. And that's usually not people they have on the payroll. And so then they also depend on some other third party company to come in and certify them that things are good. And so there's a lot of people that don't really know the full picture or whatever else. Right. So.
Sure. Yeah, that's true. It definitely takes a certain skill set to be able to hack this kind of thing, I suppose, as you've certainly found out. So now you have a Faraday cage in your house. Is that right?
Yeah. So I actually have a small one that's down here on the floor. I would rotate this thing, but I might break the whole setup.
Oh, that's fine.
But it's big enough to hold a smart meter, and some antennas and things. And it's got a lid that opens and closes. You can kind of see them in some of my early videos on YouTube. And so what that allows me to do, so when I was first kind of analyzing these devices.
And just to, I guess, clarify for the audience, a Faraday cage basically keeps all radio frequency signals in and out, right? So it's like a isolated chamber, basically.
Yeah, you think of it almost like as a sound booth, but for radio frequency waves, right? So if you look at the meter itself, if I turn this on, it's just going to start broadcasting data out kind of all over the place. And so there's a few reasons to use a Faraday cage. One, if I turn it on, I don't want it to try to talk to the network around here. And when I first started working on these, I didn't know whether it would talk to the network or not, or how it works. And I didn't understand how the network was segmented. And there's a lot that I've learned since I started. And so I wanted to just contain down any signals that were coming out. Also, so that when I'm using my software-defined radio, I also kind of get rid of any other ambient noise, and I just say, let me just focus on what is this meter transmitting and how can I understand it. Then further down the road, I started to try to talk back to the meter and to figure out how can I send messages to it. The same thing, I don't want those messages just going out over the air to meters that are around here. I want to focus it to things I own, which is the key. I can experiment on things that I own, not on things I don't own, which would be the smart meter network around me. And so the Faraday cage allows you to do that. And so when I put these devices in, it creates like a sealed environment. And it's only so sealed, though. It's like if you were in a soundproof room, but you just hit bullhorns and everything else, like people will hear it kind of outside. Faraday cages are similar. They're dampening down, but it's not going to make everything completely go away. So I also took apart some of my early meters and I disabled like the power amplifier that's in them, so that when the meter goes to transmit a message, it can't talk as loud as it used to. It's a much quieter message. And then I ensure when I transmit back, I also transmit back a quiet message. Okay. And so that's kind of, one of the tools to work on those things.
How much equipment do you need to work on to do this kind of work? I know software-defined radio stuff, you can buy those little $20 dongles from AliExpress or something, and you can receive a lot. I know they'll do a lot, but would you be able to get started doing something like this on the low end, or do you need very high-end equipment?
No, I mean, I guess that's the thing. You can kind of start with anything, right? So like when I started, I didn't start with all this stuff that I have. It's kind of, the obsession has driven the purchases, I guess. When I started, I just had an RTL SDR for $30, right? One of
and that's a software-defined radio. So basically, you can make it's act like anything, correct? Like radio-wise.
Yeah. So I guess for people, the most incredible thing about software-defined radio is, prior to software-defined radio, every time you wanted to receive a different signal from a garage door opener or a radio-controlled car or a smart meter, whatever, you had to build specific hardware that was tuned to receive that kind of signal. So what kind of modulation was it? What frequency was it on? So the cost of attack was incredibly high. Like you had to essentially be like an RF engineer and understand how to do stuff, or buy specific hardware and tune it to receive specific frequencies. What software-defined radio changed is you literally take all that stuff that was hardware and you do it on the other side of the USB. You do it on the software side. So in software like GNU Radio and other tools, you can basically tell this thing, I want you to receive on 900 megahertz. And then in the software side, you say, and we're going to decode frequency shift keying. We're going to parse the data this way and spit it out. So this can be an FM radio and tune that. It can pick up aircraft transmissions. It can pick up smart meter stuff, all for $30. And so that's amazing. It's an incredibly powerful tool, software-defined radio is, because all these things that used to be black boxes that were hard to attack, specific radio devices on all these different frequencies with different modulations and all this stuff, it doesn't matter anymore. You can just do it all in software. And depending on what program you run, this little device can do all those different things.
Yeah, that's incredible. So you can get started with one of those, just hacking a meter. You can listen to what it's saying. You can send back messages once you figure that out, I guess.
Yeah, so you can't send back with one of these low-cost ones, but you can receive. And so some of the tools that I've written that receive the data, there's a GNU Radio block I wrote called Smart Meters, GR Smart Meters, and it decodes this grid stream protocol, which is what the Landis and Gear meters use. I have a few different kind of versions of flow graph that you can open in there, and they're defined by the different radios. So there's an RTL SDR one you can open, and so it's tuned for this specific software-defined radio, or a Blade RF, or a Hack RF, or these different devices. And the difference in the software-defined radios is really how much spectrum can they receive at the same time. So, this one can receive 2 megahertz basically at the same time, around 2 megahertz. So I could listen from 902 to 904 megahertz, and anything happening in that range, I'll hear it all at the same time. But I can't listen to anything wider. Smart meters transmit from 902 to 928 megahertz. So it's like a 26 megahertz bandwidth, and they're hopping around all the time inside here, transmitting their messages, which is one of the initially hard things to deal with. It's not just like tune to this one frequency and listen in. You have to listen to everything all the time, and then grab all these little tiny bursts of transmissions and decode them and spit them out to try to get a full picture of what's happening with the network. The more expensive the software-defined radio, the more kind of bandwidth you can receive at the same time.
So if you were willing to spend the money, you could get one that listened to everything from 900 to 928 if you wanted to. Is that correct?
And it's I'd say probably for like $400 you can get one that does that. Okay. Depending on what kind of deal you get on it. A Hack RF can do 20 megahertz. So a Hack RF for $199 can almost do the whole thing. And so I got a whole ton of software-defined radios, and they're running, and most of the ones I use can pick up the whole range, and they also have transmit capabilities for other experiments, And
for anybody who wants to play with this stuff at home for $30, you can receive all day long without a license. It's legal for any of us to receive pretty much whatever we want to. Is that pretty correct?
So I would say probably, I'm not a lawyer, so legal to receive that, that in itself is probably topic for a whole other conversation. But there's nothing illegal about generally receiving data, especially in a band like this 900 megahertz band, because it's called like an ISM band, which is industrial, scientific, and medical devices. So it's an open, license-free band, which is one of the reasons the smart meter company chose it. They don't have to pay anything to use that frequency range, but there is a bunch of other stuff in that range as well, so they had to come up with a communication scheme that could hop around and be resilient to other transmitters that might be in that range, since everyone's allowed to use it license-free, basically.
Wow. Well, this all sounds, it sounds very simple and easy to do, but at the same time, very, very hard from a specific standpoint. Is there, say, a website somebody could go to see what where other people have started on projects like this, maybe get some tips?
So there's my wiki that I've set up, which is called Recessim. It's RECESSIM, so wiki.recessim.com. And what I've tried to do there is there's a lot of stuff about smart meters. There's also stuff about other projects that people are working on. And it's free to create an account over there and to kind of, post your own stuff you're working on. And the idea is to have a place where people can, put their reverse engineering projects they're working on so everyone else can see what's being worked on and try to share ideas. I also have a Discord channel where a bunch of people, we chat about different things like that related to reverse engineering. So that's one sense. Now and on there I link things like Travis Goodspeed has some good articles. He manages a thing called POC or GTFO, which is like a whole reverse engineering journal, and he puts those out for free. I have links to those on my site as well for people to check out.
Very, very awesome. And that's Latin for going backwards? Is that right?
Yeah. So Recessim's Latin for moving in reverse. It's also a free. It was free on the .com side, which is always a challenge, is finding something that's available. So I wanted something that, pronunciation wise, it's a bit of a challenge because how do you say it? But I was looking for something that was available, and it's something that that meant something at least related to what we're doing, which is reverse engineering. And so I encourage people to post anything on there. A lot of times the challenge when you're starting out is, especially if you look at something maybe that's a project that's further along, like if you go look at all the smart meter stuff and things that I've posted, there's a pretty good amount of information. It's like you have to keep a couple things in mind. I've been working on that for a couple years at least, right? So that's not 1 week's worth of stuff. I've also been doing this kind of for a long time, and so I always encourage people, just take something apart that's interesting that you can't find anything about and post some pictures. Like that's the first step. Just someone else can find some pictures and then maybe they contribute something and add some other piece, or as you go further, you add some more pictures or some information. What are the components that are used? So to break it apart into smaller chunks, but to err on the side of sharing stuff that maybe you're unsure about versus trying to have this full great picture and you're going to post a finished product, right? It's never really finished. It's kind of always ongoing. Oh,
for sure. It's shameful how many projects I have that I never quite get finished. Or maybe it's not shameful. I don't know. Maybe that's something I should be proud of.
Yeah, I think I'm fine with not finishing stuff anymore because it's fun to start stuff. I do like to try to at least document it a bit. Which that's always a challenge. I don't even do it as much as I would like, but to post some stuff on the wiki or to put things out there and document it, because then when I do go back to it, at least I've got a record of where I was. And if somebody else wants to kind of jump in and help, well, they can also see where things are. And that's where I notice a lot more as people join my Discord channel and things, and they start asking questions. Me and the other people are usually like, as they figure stuff out, we're like, hey, you should probably put that on the wiki. Like, that's great information, so the rest of us can advance what's happening.
Well, that's awesome. It seems like something that, maybe there's not a, that's awesome to hear there's a resource for that. Cause otherwise it seems like, before, I guess when we were growing up way back, whenever that was, there probably was a lot of stuff you just had to figure out. Everybody had to invent their own individual wheel, and that's not the most efficient way to do anything. So.
Yeah, I would say that so I've noticed a similar thing, that a lot of people have blogs. They have different places they post stuff. You might be on Twitter and there's a thread somebody starts of good information, but it just gets lost over time, and it becomes hard to find it when you're working on stuff. And so a long time ago, I worked on reverse engineering this little LiDAR that was on a robotic vacuum, this Nito vacuum. It had a little LiDAR that it used to map your room. And there was a challenge that was put out to see if anyone could reverse engineer this. This was like 10 years ago, probably. And I did that, and I managed to win the challenge. There's like some links to things online you can see. But as I was doing it, I created a wiki on this place called Wikispaces that I think it no longer exists anymore, and I had to take the thing down. But when I created that wiki and started posting just what I found, like 100 other people that joined this thing, and everybody started kind of group reverse engineering this robot and posting every single thing about all the different areas. And it just out of nowhere, right? A shared common interest of posting stuff and helping each other out. And so I was a little irked when they went out of business and had to pull the stuff down and it went away. And so I thought, when I started doing this, I thought, I'm just going to create my own site. I'll pay for the hosting. I'll set up this media wiki thing and everything else to run it, and just make it free for anyone to come and join and post stuff, because there's a lot of value in that. And it's like you're saying, when I was younger, you'd search the internet and find stuff, and you did manage to find stuff. That was awesome, and it helped you advance. And so I kind of think the same way. Like, it's nice to help people advance and to help other people that are searching stuff, and you never know where they are in life and career or aspirations. So it's cool to have a resource, that's just out there with stuff like that.
Yeah, that's awesome. Well, I guess I was thinking, Pat, you want to go ahead and take the coffee break, and we can come back and ask some more questions of Hash?
Jeremy, I would love a coffee break.
Yeah, so we'll take a coffee break. We'll be right back, and we'll have some great questions. So, or good questions at least. We'll see what happens.
Or at least questions of some
sort. Or at least questions. So you hit record, I guess, Pat. Welcome to the coffee break. This is the Create/Invent podcast, and this is where we, I guess, talk about how you can support us. First of all, we love it if you leave like a thumbs up or a comment, or just leave some sort of interaction on whatever medium that you're listening and or watching this on. Right, Pat?
It's true. That gives the medium that you're watching it on, like a YouTube or a SoundCloud or an iTunes, it lets them know that you're participating, and that's nice for us. That helps us out tremendously.
Of course, as we do every week, we want to give a shout out to our top 5 Patreons. Right, Pat?
We do, and I'm going to count. I've got both hands ready for numbers.
All right, so first of all, we've got Carl, and Carl had a special request that we turn up the volume on our podcast. So we'll try to work on that for you this week, just for you, so you don't have to adjust the volume when you're in your car. Michael Sizer, we like you as well. You were on the podcast one time, so that was awesome. Raptor, creatively spelled. You're the only one who spells your name that way on the podcast. Stuart Morrow, you have a standard spelling, so that's good too. Brian Moses, also a fairly standard spelling. And then Positive Waves, standard spelling, but he's got a underscore in his name as well. So just wanted to point that out. So anyway, thanks all of you for your patronage, your help out on the podcast, and we'll try to get the volume correct for all of you.
What if I wanted to become a patron of the Create Event podcast? How do I become a patron?
That's a good idea. We probably need to figure that out. So you go to patreon.com/createinvent. Is that right? I don't even.
Does that work?
I always forget.
Because mine still says the Creativity Podcast. Oh, yeah, you're right. You could go to Create Invent, all one word. Oh,
patreon.com/createinvent. Yes, create/invent. In fact, if you want to go to Patreon, it's patreon.com/createinvent. No secondary slash or anything. You know what I'm saying, Pat?
I do know what you're saying. And I will also make sure everybody knows you don't have to become a patron. We won't be mad if you're not a patron, but we do appreciate all of our patrons. It makes us it makes us feel very appreciated. And I'm very appreciative.
Thanks so much. And we'll get you back to your show with Hash.